positive and negative feedback circuits. Okay, so I just draw the circuit like this is my V in, this is adder. Here I apply one particularly amplifier. The gain of amplifier is A. We are getting the output. From the output, we take some particularly part of the signal, multiply with the feedback. Okay, this become plus, this become plus. Okay, so now your A is plus, F is plus, and this become plus. So which type of feedback is that? This is the
Negative feedback.
positive feedback. Okay, this one is the positive feedback. Now the addition of the feedback signal as well as the V in create the error signal. So what is the value? VE is equal to V in plus F time V out. Okay, and what is the relation between the VE and V out? VE is nothing but V out upon A. So if I put this particularly V value here, so we are getting the V out upon A is equal to V in plus F time V out. Okay, take a common V out taking this side and take a common, so V out 1 upon A minus F is equal to V in. So V out 1 minus AF upon A is equal to V in. This implies V out is equal to A upon 1 minus AF times V in. So if we are getting a negative 1 minus AF in the case of positive feedback. Okay, now it will be 1 upon F into AF upon 1 minus AF time V. Multiply the F from the in the numerator and denominator, so this becomes the AF. This AF is called the loop gain. Okay, this AF is called the loop gain. Now similarly, if we have a negative feedback, the circuit should be like this is A, V out, V, V in, F. This will be subtracted. Okay, this will be subtracted. So my error signal V is equal to V in minus F time V out. Here it is a plus F time V out. Okay, now here is a minus. So what changes will be here? This particular symbol will be plus. In place of minus, it become plus. If this one is a plus, 1 plus AF term will be there. So I just directly route V out is equal to A time 1 upon A upon 1 plus A beta time B. Multiply with F, so F and F. Okay, so this is my positive and negative feedback. How we check that which particularly feedback is this one? either it is a positive feedback or it is a negative feedback. So what we do, for every circuit we have to break a loop. Okay, either from there I just break a loop, minor changes in the signal, I just increase a minor value. Okay, so what is the effect that is coming at this point will be decided that the signal will be the feedback will be the positive or negative feedback. So if I change the minor changes, so it multiply by the feedback gain, so it is again a minor changes in the positive direction. Okay, minor changes in the positive direction. Now it will be subtracted, so it will be reduce the value. Now if it will be reduce the value, so a multiply by the value multiply by the reduction of the value will be highly reduce the value. So when we increase the value at this point, we are getting that the signal will be decreases. So there is a 180-degree phase shift. 180-degree, how we say the 180-degree phase shift? Because when we increase the signal, the output should be always increases. But here the thing is that the value will be decreases. So if there is a 180-degree phase shift, so we can say that it is a 180-degree phase shift or a negative phase. Similarly, if we go with this circuit, break the loop, minor positive variation in the signal, here the same, it multiply with that the positive. This positive signal add with this one, though it will be increase the value of V. This V value multiply with A, so it will be also increase the value. So we done the positive changes in the signal in a positive direction, and we are getting the signal will be vary in positive direction. So that means there is no phase shift. So it is called a positive feedback. Okay. Now, in the most of the scenario, the operational amplifier will be working as a negative feedback. Either it is a inverting amplifier or it is a non-inverting amplifier. Okay, for every scenario, this particularly will be behave as a negative feedback circuit. The reason behind the negative feedback is it is easy to solve. How it is easy to solve? We are considering that when operation amplifier will be working as a negative feedback, so it behave as a virtual ground. It behave as a virtual ground. So there are two terms. One is the virtual ground and second is the practical ground. Okay. So practical ground is that where ideally the potential is 0 volt, and virtual ground is only the voltage is not equal to the 0 volt, but we can consider as a reference voltage. Okay, we can consider as a reference voltage. So we are considering that operation amplifier will be working as a virtual ground. Now, what is the meaning of virtual ground is that, like if this is an operation amplifier, either the input signal apply on a positive terminal or the input signal apply on a negative terminal. Okay, either the input signal is applied on a positive terminal or a negative terminal. Here, if you see that it is a V in is connected on a positive terminal, and in this circuit second you are seeing that input signal is applied on a negative terminal. In both cases, check that this particularly will be a negative feedback. How it will be a negative feedback? How we check that it is a negative feedback or positive feedback? Like I have a circuit. Okay. So where is the loop? The loop part is this one. The loop part is this one. Okay. How we check this loop is a positive loop or negative feedback? Break a loop. So I just break a loop from here. Increase the voltage. Okay. Now from this loop it will be go to this part negative through the negative terminal. It will be coming again on this particular terminal. So when I increase the voltage increases here in the positive direction. The resistance will drop the voltage level, but again it is in a positive direction. Okay, like for example, I change the voltage by 1 volt. Resistance is 1 kilo ohm, 1K. So maybe possible the voltage drop here is at 10 volt, 10 millivolt, or 1 millivolt, but it is always in a positive direction. It is always in a positive direction. Now, again, here the voltage is in positive direction. Now this voltage will be multiplied with the negative, so that means the voltage will be in negative direction. Multiply with the gain of amplifier, operation amplifier A, so it will be the voltage in the negative direction. Okay, voltage in the negative direction. So you can see when I change the voltage in a positive direction, I will reflect come in the signal will be coming back in a negative direction. So it is a 180-degree phase shift. Okay, or we can say the negative feedback. Okay, so the first thing when we are solving the operation amplifier question, we have to check whether the circuit is positive feedback or negative feedback. Okay, this is the first thing. Now, if should I even speak something? Yeah, Vishal. Vishal, better that you can ask a question because when you just raise your hand, I can't see. That's why better that you can ask the question directly.
Sir,
Yes.
I've
Yeah.
texted you. It's in messages form. Oops.
So, what is your question?
Sir, it's in the message inbox. I
Okay.
I can't actually speak here.
Okay. 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 Uh, can you please repeat how did we conclude it is a negative? Okay. Like I just take one more circuit. Here I am not giving a sign. I am not assigning which terminal it is. Like this is a V in resistor, resistor. This is a ground terminal. Okay. Now I have to identify the terminal for a negative feedback. So what I do? Break a loop. The first thing is break a loop. So first of all, identify which is the loop. Identify which is the loop. So if you see that this particularly is a loop. When the signal go from this one, it will be go from this one and it will be again coming back. Okay. So this is output signal, V out. If you compare this signal with this diagram, A, V out, it will be going back with a multiply of feedback circuit, and it will be either subtract from V in. So this is V in. So V in is coming from this point. Okay. This point is basically replaced by this one. So if I replace here like a summer, okay, this point is point two is here point two, point one is here point one. Okay, the signal will be going, output signal will be going from the feedback. The output signal will be going from the feedback. So this is the F, and that particularly from the point A, the signal will be traveling through the A to point two. So this is A. So can you relate this particularly with this feedback circuit? Yes or no? Can you relate this operation amplifier, this circuit with the this feedback circuit?
Yes, sir.
Yes, yes.
Okay. Now, if I am considering, I just break this loop from here. Increase the voltage. Okay. Now the voltage that will be increases passes through the resistor. The circuit current will be the circuit voltage will be applied through this one. We pass particularly signal in this way and check whether the signal is in positive direction or in negative direction. Okay, so when this particularly increased voltage will be passed through the resistor only change the magnitude, but it doesn't convert the positive voltage into the negative or negative in the positive, because resistor is a any without any polarities. Okay, resistance doesn't have any polarities. So when we apply the signal, when we increase the signal in a positive direction, resistor will decrease the magnitude, but it not change the sign of that one. Now the signal that is applied in a positive direction will be appear at a positive direction. Again, it will be appear at a positive direction. Now, if this positive signal without multiply with the minus sign, if I multiply directly with the A, the signal will again in a positive direction. Okay, and if I this signal will be multiply with the minus sign and multiply with A, so it becomes in a negative direction. So when this terminal is positive, when this terminal is positive, the voltage in a positive direction. When this terminal is in negative, it becomes as a voltage in a negative direction. If it is become positive, the voltage in positive. If it becomes negative, voltage is in negative.
So, sir, it mainly depends on the feedback voltage,
It
the feedback
depends on the
sign.
feedback voltage, but it will be either reduce or I am not saying that it is completely in zero or in the negative direction, but it will reduce the signal. I increase the signal, like it is a 1 volt. Here I am getting a 10 millivolt. Okay, if I reduce, if this particularly is 10 millivolt, here I am saying that it is a 1 volt. So what we are getting here, 1.01.
Yes, volts.
Okay, now if it is a positive, so it becomes positive direction. If I multiply with a negative, so it is minus 1.01 volt. So complete signal will be, I apply the plus 1 voltage, I increase the signal by 1 volt, but I am getting a minus 1.01 volt. If the A is 1, so I am getting a minus 1.01. If the A is 2, I am getting a minus 2.02 volt. So the polarity is changed. I apply the positive signal, I am getting a negative signal. Clear? Yes or no?
Yes, sir.
Okay. If you have any doubt, you can ask the question. No issue. If I want to repeat it again, I can repeat it. Okay. So for the negative feedback, it is compulsory that this particularly will be negative, this become positive. Okay. So first thing, I have to check. Again, anyone is writing or something. Yeah, we have just added, but we multiply the signal with minus because it is a negative polarity. I just say that if we go with the minus f and this become plus, so it is again a negative feedback. Or either I say that if f is plus but a is minus.
Okay, okay, sir.
Okay. The thing is that either I apply the voltage in a positive direction or increase the voltage in a increase the voltage in a positive direction. I will reflect the signal that is coming back through the loop. It will be the negative in the negative direction. This is the best way to check the signal. The particular circuit is a positive feedback circuit or negative feedback. The first thing is that we have to check the circuit is positive feedback or negative feedback. Okay, if polarities is given, you just check. If polarities is not given, you consider that which by which polarity it becomes behave as a negative feedback. Now after checking that your circuit feedback is a negative feedback, you have to apply the virtual ground concept. What is the virtual ground concept? Virtual ground concept consider that the voltage at a positive terminus becomes equal to the voltage at negative terminal. Like if I am considering that the voltage at this point and the voltage at this point will be same. Why? Because it is a wire. It is a wire. There is no particular resistance across that the voltage will be dropped. So the voltage at this point and voltage at this point become same. Now voltage at this point and voltage at this point become same. This is the genuine, okay, in the circuit. Now the voltage at a positive terminal is what? It will be connected with the ground. We are using the ground in this way, or we are using the ground in this way. Sometimes we are using the ground in this way. Okay, but mostly this is the ground. Okay, I am using only this particular line for the ground purpose. So that means the voltage at a positive terminal, like it is connected with the ground, so this particularly point is the 0 volt, this voltage is the again a 0 volt. Now according to the virtual ground concept, the voltage at positive terminal and voltage at negative terminal becomes same. So this is also the 0 volt. If this becomes 0 volt, this becomes 0 volt, that means the drop across this resistor. We discussed the internal diagram of the operation amplifier in the previous class. I just repeat it again. Ground, source, R out, R in. Okay. The voltage at this point, if I consider the V1, the voltage at this point we are consider the V2. So the voltage drop across this resistor is V1 minus V2. Okay. Now this particularly voltage source voltage is A times V1 minus V2. A times V1 minus V2. So A is the gain, V1 minus V2 is the voltage difference between these two terminals. Okay, so if the voltage at this point is 0, the voltage at this point with 0, so that means the voltage across this resistance is 0 volt. If the voltage across this resistance is 0 volt, that means the source voltage is also 0 volt. So if source voltage is 0 volt, this particularly voltage is 0 volt, that means no current will be passing through operation amplifier. No current will be passing from the operation amplifier. Is it clear? Any doubt?
No, sir.
Okay. If the no current will be passing through the operation amplifier, that means the current that is passing from this started from the V in passing through this resistor will be passed through this direction. And we are getting this particularly here. Okay. Can you write a KCL equation? Here I am getting a 0 volt. This particularly voltage is V out. So can I apply a KCL at this point? So incoming current, if I say the current here is I1, the current is I2. So incoming current is equal to the outgoing current. So I1 is equal to I2. What is the value of I1? The voltage drop between these 2 points upon resistance. So if I this resistance is R1, this resistance is R2. So I1 is V in minus V, I am considering Vx. V in minus Vx upon R1. That should be equal to Vx minus V out upon R2. Now we know the Vx is 0 volt. Why? Because of virtual ground concept.
Yes, sir.
Yeah. Any doubt?
No, no, sir.
Okay. So V1 minus
Uh,
Vx is 0 volt. So I am considering this is the 0 volt. So what is the V out? V out is equal to minus R2 by R1 into V. Okay. So the input voltage that is applied at a negative terminal we are getting the output voltage with the negative sign. This R2 by R1 is nothing but the gain A. So V out is equal to minus of A time V in. Okay. So if I am getting the output voltage with a negative sign, so can I consider this negative terminal of op-amp? This particularly terminal of the op-amp is called the inverting terminal. Why inverting terminal? The applied voltage is just invert receive at the output side. The invert of the applied voltage will receive at the output side. Okay, or we can say we are getting a V out and V in with 180-degree phase shift. That's why this negative terminal is called the inverting terminal. Okay, and if input signal applied at negative terminal, it is called the inverting. Okay, and if A is the amplifier gain, if A is, like for example, greater than 1, in the most of the cases the value of A is greater than 1, but I am not considering what is the value of R2, what is the value of R1. I am considering that if A is greater than 1, so output voltage is the increased voltage as compared to the Vin. So I can say my output voltage is the amplified version of the input voltage with negative sign. Okay, if A is greater than 1, so output voltage is amplified version of input voltage with negative sign. With negative sign. And this, because of this negative sign, we call the inverting, and because of the amplified version, we called as the amplifier. So that's why the term inverting amplifier will be used. Okay. Now, what happen if I apply the voltage at a positive terminal? So this is my operation amplifier. V out. Now this is my circuit. First of all, I have to identify the terminals. So what I do, I have to convert this circuit with negative feedback. Break the loop, increase the voltage. So the voltage that is increases, it will be also affected here. The voltage is also affected here. Now if I multiply with the minus sign, okay, if I multiply with the minus sign, the voltage will be in negative direction, multiply with the amplifier gain, so we are getting the voltage in the negative direction. Okay, so this become negative, this become positive. So we identify the terminals, which one is the negative terminal, which one is the positive terminal of the operation amplifier for negative feedback. Any doubt in this one? Any doubt in this?
No,
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 sir.
sir.
Okay. So we decide that this is a negative feedback when I connect this plug. Okay. Now, if this is the R1, this one is the R2. What is the voltage drop at this point? Vx. This is a 0 volt. Okay. So the current will be flowing in this way. V out is the voltage because we apply the input voltage, so we are getting the V out voltage that is greater than 0, and this terminal is the negative grounded. So this particular terminal is a higher potential, and this terminal is a lower potential. So current will be flowing in this way. Current will be flowing in this way. Now can I draw this one is that this is my V out, R2, R1 grounded, and this point is Vx. So what is the current in this path? V out upon R2 plus R1.
Yes, sir.
What is the voltage drop at this point? This current multiplied by the R2 is the voltage drop. So V out upon R2 plus R1 into R2. This is the voltage drop. What is the voltage drop here? V out upon R2 plus R1 multiplied by the R. Okay? Now, I assume that it is a negative feedback. That means no current will be going in this direction. No current will be passing from the operation amplifier. All the current will be passing from the outside of the operation amplifier. So if no current will be passing from that one, that means this particularly voltage V in will be appear at this point also. Can you tell me why?
Sir, can you please repeat?
Yeah, I just say that if current is not passing through the operation amplifier, so that means from this wire no current will be passing. If no current will be passing from this point, so I can say the voltage drop across this resistance becomes zero.
Yes, sir.
If voltage drop across this resistance will be zero, that means V in voltage that is applied at this point is similar to the voltage at this point.
Voltage at V naught.
This point.
Yes, sir.
V positive.
Yeah.
Okay, because current is not flowing. If current is flowing, so the voltage at this point is V in minus current multiplied by, if I say, the Rx, current
Yes, sir.
multiplied by the Rx.
Yes,
But
sir.
current is zero. Why current is zero? Because it is a negative feedback. In the case of negative feedback, we are considering the virtual ground concept.
So at that point, it will be straight away VN.
Yeah. So in the virtual ground concept, this voltage and this voltage is similar. So if these voltage is similar, no current will be passing from this operation amplifier. Okay. So that means there is no current will be flowing in this way. So the current is zero. So I can say at this point the voltage is V.
Yeah, yes, sir.
If this voltage is Vn, due to the virtual ground, this voltage is also Vn.
Okay, sir.
Okay.
Yeah.
Now the current in this particular branch is Vn by R1, because this voltage is Vn. This is ground terminal. So the current in this branch is Vn by R1.
Mm, okay, sir.
The current in this branch is
VN by R2.
V out minus V in by
R2.
R2, and both current will be same.
Yes.
So V in by R1 is equal to
V
V
out
out minus V in by
R2.
R2. So V in 1 upon R1 plus 1 upon R2 is equal to V out by R2. R1 R2, that is R1 plus R2, is equal
Yes,
to V out by
R2.
R2, and R2 cancel out. So V out is equal to V in 1 plus R2 by R2.
Yes, sir.
Okay?
Yeah.
Yes, sir.
Yeah? Any doubt?
No, sir.
No, sir.
So we are getting the V out is equal to V in. Now, if we are getting V out is equal to V in 1 plus R2 by R1. So this 1 plus R2 by R1 is amplifier, because the magnitude is always greater than 1. Either R2 by R2 by R1 is less than 1. After that, this particularly component is 1 greater than 1. Okay, so this is the amplifier. So V out is equal to A times V in. Positive sign and amplified version. So it is called a, due to positive sign there is not inverting, so it is called the non-inverting, and due to the amplification it is called the amplifier. Okay, so there are two types of amplifier: positive amplifier or negative amplifier. Now If I use the circuit, no issue in that one. Why? Because if I connect a resistance here, okay, what I do, I just use a non-inverting terminal at the upper side and inverting terminal as the lower side. So basically it is a vertical mirror. Okay, either I use a resistance or I use a direct wire, there is no effect of that one. Why? Because the current through this resistance I to Rx becomes 0. Okay, I through Rx becomes 0. So when the current is not flowing from that one, so it behaves as a there is no effect of that resistance. So either should I connect with a straight line or either I should connect with a resistance. There is no effect of that particular resistance. Clear? Sometimes you can see that this particular circuit should be like that. Okay, again similarly concept, if the voltage here and the voltage here, okay, if it is a V in voltage because of this particularly voltage, so this voltage is this current is V in by R1, the current that is flowing this particularly circuit, that is current will be flowing in this way, current will be flowing in this way, no current will be passing from this one. Why? Because it is a virtual ground concept. In the virtual ground concept, no particularly operation amplifier, no current will be passing from the operation amplifier. So if no current will be passing from the operation amplifier, so this particularly is a no current. Okay, so all current will be passing from this one. Okay. The voltage drop at this point is V in by R1 into R2. Why? Because if this current will be passing from this point, okay, if this current will be passing from this point, so that current will be flowing from this way. So if I say that the current is V in by R1, so where this current comes, this current will be coming from this one. If the same current will be coming from this one, so the voltage drop across this resistance R2 is V in by R1 current multiplied by the resistance. Now the voltage this point and the voltage at this point both will be added to become convert as a output voltage. Okay, so V out is equal to V in. Can I take a common V in? So there is a 1 is remaining and from here R2 by R1 is remaining. So again the answer is V in 1 plus R2 by R1. Okay, you can go through with any of the method, the output, the V out equation will be same, that is V in 1 plus R2 by R1. Now someone is saying, yeah, someone is saying anything? Okay. Any doubt? Yes, any doubt?
No, sir.
Okay. So I think that's it. The part of week one. In the week one, the professor discussed this thing only. There is one more
Um,
concept in the
but
particular
in
week.
week one, I have one doubt.
Yeah.
In lecture 5,
Lecture 5. Can you tell me what is the doubt basically? Because I am not remember which is the week lecture 5.
okay, it was regarding that with the current source, he had explained one amplifier circuit.
Voltage control current, so VCCS.
Voltage control.
Wait a minute, I just checked. In this video, you are asking.
Yes, sir.
Okay.
Here, sir.
This point.
At this point, yeah.
Yeah.
So he this minus a into vx, that part I got little confused.
Minus A into Vx. Why we are taking the minus A into Vx is that my uh, this is my Vx point. Okay, I am taking the Vx point. This one.
Okay,
Okay. Now the
okay,
current is going in this direction, lower direction.
okay,
So this particularly voltage has a less potential. Okay, Vx is they are explaining one thing here. Mm, yeah. So now what they consider that it is a voltage, positive voltage source. Okay.
okay,
Now if I convert this particularly with the yeah. Why they are taking the minus AVX? Because we are using the operational amplifier in a in a negative feedback.
right,
Okay. So
yeah,
what we are getting is that every time we are getting like a invert of the amplification gain. If
okay,
I am using the particularly negative feedback circuit, so what I am getting like if we go with this one, so either we are getting a point Vx here, okay, and this
okay,
multiply with the minus, okay. Now the gain is amplifier gain is A. So what
okay,
I am getting here minus A time Vx.
Okay.
in the negative feedback point. Only we are getting when it is a Vx value, this point is a Vx value, it is multiplied with a negative sign. Why? Because we have to create a negative feedback. So it becomes minus Vx. Multiply with the gain of the amplifier, it is a. So it is a minus AVX. So that's why they particularly represent that minus AVX.
Okay. Okay. The confusion part was like when we are using uh, instead of a current source, when we are directly giving a this thing, there he only uses A into VE. Like,
That a error signal is that, okay, they are taking that. If we are taking the feedback, so in this particularly feedback, it is an error signal. Error signal should be positive or should be negative, okay.
okay.
So that particularly error signal V is nothing but the combination of V in minus F time of V out. So
Okay.
we are considering a minus sign here in the
Okay.
feedback. But if
Okay.
this is a resistance, if this is a resistance, the resistance is not minus F. Resistance is always a R.
Oh, okay.
So what I do, I just multiply with the gain.
Okay.
That is negative to convert into the minus negative feedback.
Oh, okay. Okay, sir. Thank you, sir.
Okay.
Yeah.
Any other doubts? Yes. Any other doubts? No.
No, sir.
Okay. So we stop here. See you in the next class. Ideally, probably on Tuesday, 6 to 8. Thank you all.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Attendance will be tracked through the Google Meet. When you join particularly Google Meet, this particularly meeting, automatically attendance will be tracked.
Sir,
Yeah.
is the quizzes be subjective or objective?
Quiz will be subjective.
Okay, sir.